What is the gravitational potential energy of a system of two masses? The gravitational potential energy of a system of two masses is given by minus gm1 m2 divided by r. Okay. One more formula. Suppose this is point A and suppose this is point B. Point A and point B. So we know the potential at point A and we know the potential at point B. So if there is a mass m and we want to carry this mass m from VB to VA. So carrying the mass from VB from point V to VA, point B to point A. So in this process, the work done will be work done in carrying the mass from point V to A. So there is a relation between this work done and the potential difference. The potential difference will be VA minus VB is equal to the work done in bringing the mass from B to A divided by the mass m. This work done can be the work the work done by the gravitational force. This work done can be work done by the electrostatic force, or this work done it can be equal to the external work done also. So these formulas will be required. Okay. So one by one we will solve numericals. So first I am taking the simplest numerical. This. These questions I have taken from your book. So they are asking in this question, how much work is done by the gravitational field? How much work is done by the gravitational field in moving a mass m, from mass m of 2 kg from infinity to point A, from infinity to point A, and that point A is 0.40 meter from a mass m of 30 kg. So basically the condition is this, this is a point A and this point A is here and this is separated by a mass m. Here is a mass m, capital M, and this capital M is equal to 30 kg and this is a point M, A. So they are asking how much work. This is the infinity and here at infinity a mass is placed, mass of 2 kg is placed. So they are saying to carry this mass from infinity to point A, how much work is how much work the gravitational field will do. Okay, how much work is done by the gravitational field in moving a mass m of 2 kg from infinity to point A. So very easy. I told you that work done in bringing a mass from one point to another point, Okay, so there is a relation between the work done and the potential. There is a relation between the work done and the potential. So the potential difference between 2 points is equal to the work done between 2 points divided by the mass. Okay, so these are the 2 points. These are the 2 points. Okay, these are the 2 points. So work done between these 2 points will be work done in carrying the mass from infinity to point A. So this work done we have to find. Okay, and there will be the potential at point A and there will be the potential at point infinity. And I told you that at infinity always the potential energy as well as the potential at infinity we will take 0. So potential at infinity is 0 and potential at A will be potential due to this mass, that is minus gm by r, that is minus gm by r. Okay, so this value is minus g into m by r. Okay, so gmr is this distance. Okay, so we will put that. So now we can say that va minus v infinity, potential difference between 2 points, va minus v infinity is equal to the amount of work done by the gravitational force in the amount of work done by the gravitational force in moving the mass of 2 kg from infinity to A and divided by the that 2 kg mass m. Okay, so m here is 2 kg. So now VA is this, V infinity is 0, and this work done we want to find. So we want to find V infinity minus V work done from infinity to A is equal to mass into VA minus V infinity. Now V infinity is 0, so we will put this value is 0, so it will become M into VA. So what is the value of M? M is 2 kg, so put value 2 kg, and this is what? Minus Gm by R. Okay, it is minus Gm by R. Okay, now put all the values. So it will become minus 2 Gm by R. Okay, so 2, okay, minus G. G is 6.67 into 10 to the power minus 11, and this mass capital M. Capital M is 30 kg. Capital M is 30 kg. So this is 30 kg. Divided by R. What is the value of R? R is 0.40. 0.40. Okay. So this value you will get approximately equal to 1.005 into 10 to the power minus 8 joule. So Shavardi, do you have calculator? Just please do it fast.
Yeah, okay.
Yeah. So approximately your answer will be minus 1.00 and one more 0 and 5 into 10 to the power minus 8 of joule. I think this will be the answer. Please check.
Yes, it's the same answer.
Hmm. So now you should have idea how to solve the question. That is why I told you the topic, the potential, because with the help of the potential we can find out the work done. So that is why I told you that topic, the gravitational potential, and we have done derivation also. So now we have used this formula only, minus Gm by R, and I have told you the story behind it. Okay, now next question. Next question. So the next question is this. Hmm. Next question is this. This question is also from your book. Okay. So read this question. The Earth has a mass of 6 into 10 to the power 24 kg and radius 6.4 into 10 to the power 6 meter. They are they are saying find the change in the gravitational potential energy. Change in the gravitational potential energy of a meteorite of mass 150 kg. There is a meteorite of mass 150 kg as it moves from infinite distance to the Earth's surface. So, a meteorite is moving from infinite distance to the Earth's surface. We have to find the change in the gravitational potential energy. After that, what they are saying? They are saying the meteorite starts from rest. Start from rest means the meteorite starts from rest from infinity. Okay, and after that, they are asking with what speed does it strike the earth? With what speed does it strike the earth? And gravitational constant capital G is given.
So,
So
do
what you
we
will
use
do means,
gravitational potential energy or?
yeah, we will use obviously we will use the gravitational potential energy. So okay, let me tell you how to do this question. You have to, when you are solving now, so always try to make the diagram. So basically this is the earth and this is the earth, and R is the radius of the earth, M is the mass of the earth. Okay, and somewhere here is the meteorite, and this meteorite is having a mass of 150 kg, and this is moving from infinity. So this meteorite is at infinity. Okay, so this meteorite is moving from infinity to this earth surface. Okay, infinity to earth surface, this meteorite is moving. Okay. to the Earth's surface. They are asking, first they are asking what is the change in the potential energy. So basically this will be the initial position, this will be the initial position of the meteorite, and Earth's surface will be the final position of the meteorite. So we will find first the initial potential energy and after that the final potential energy. I told you at infinity the potential energy of every system is zero. So potential energy at initial potential energy will be potential energy at infinity. Initially the meteorite is at infinity na, so the potential energy at infinity is zero na. Or in other way you can solve this question, you can solve that. Two masses are there, there is one mass m, there is another mass this. What is the gravitational potential energy of system of two mass which are separated by a distance of infinity? U is equal to minus G capital M small m divided by R. Okay, so it will be minus G into M capital M divided by R is infinity and 1 by infinity is 0. That is why the initial potential energy you can say it will be 0. You can do with the formula, or I told you that for the reference purpose we assume that the potential energy of the system at infinity is 0. So potential energy of this mass at infinity means potential energy of this earth mass system at infinity when this mass is at infinity is 0. Now understanding na Shafdin? So basically initial potential energy is 0. Now finally the meteorite is here, so final potential energy. So final potential energy, again we will apply the same formula, minus gmm by r, but this time this r will be this r. Okay, this r will be this r. So minus g into mass of the earth into mass of the meteorite divided by the radius r. So this will be the final potential energy. So they are asking the change in the potential energy. Change in the potential energy, delta U. Delta U means change in the potential energy, and change in potential energy is always final potential energy minus initial potential energy. What is the final potential energy? This is final potential energy minus gmm by r minus gmm by radius of the earth. Initial potential energy is 0. Initial potential energy is 0, so this is 0. So you have this value, we will calculate this value. So we know the value of G is given as 6.67 into 10 to the power minus 11, and mass of earth is given, I think, 6 into 10 to the power 24. 6 into 10 to the power 24. 6 into 10 to the power 24 multiplied by the mass of the meteorite is 150 kg. So this will be 150 kg, and radius of the earth is 6.4 into 10 to the power 6. 6.4 into 10 to the power 6. So this value approximately, you will get this value approximately. I have already calculated this value. Change in potential energy, no? So change in potential energy will come out to be the value I calculated already. I think. Oh, they are asking change in the gravitational potential energy. No? So change in the gravitational potential energy will be 9.37. You should also calculate this. 9.37 into 10 to the power 9 joule. Just please do it by yourself also. Do it by yourself, and negative sign is there. Calculate this value.
Yes, I'm getting like very big numbers.
Very big numbers. Just tell me numbers.
93796875000.
Okay, you are means you are not getting answer in this form. So basically, then if suppose this question will appear in your exam, then what you will do? So you can write that value also. But if you will write in this form, then it will be better. So
Okay,
basically,
okay.
suppose it is written that, like I'm telling you, it is written 93700000000. It is written. So first count the total numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 numbers are there, na? So what you have to do now? If you want to write this form into this form has a 9.3. 9.3 if you want to write now. So when you will uh, apply point here, okay. So for example, simple example I am taking. This is 112. If I want to write it in this form, 1.1 in 1.12 I want to write, okay, 1.12. Then how many zeros I will add, multiply in 10 power 10 power 2, 10 power 2, 1.12 into 10 to the power 2. So means you have to count these numbers. So count these numbers if you want to write 9.3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9.3 into 10 to the power 10. Understanding now how you have to write in the scientific form.
Yes, sir.
Suppose it is written as 56752, and you have to write this in this form, 5.6 multiplied by 10 to the power x. So can you tell me the value of x fast?
3.
1, 2, 3, 4.
Of
4. Okay. So next part they are asking, we have calculated the change in the potential energy when the meteorite will move from infinite to the surface of the earth. Now they are asking, with what speed does uh, it strike the earth? So meteorite moving from infinity to the surface of earth, there will be some velocity with which the meteorite will strike the surface of the earth, and that velocity they are asking. So okay, there is a velocity. So suppose v is the velocity with which the meteorite is striking, and that we have to find. So now what we will do? What we can do?
You can take V by
No, this is not the potential. This is velocity. V means velocity here. Velocity of striking with the earth. Very simple. I told you that conservation of mechanical energy. Conservation of mechanical energy means the initial mechanical energy means the potential energy plus kinetic energy. Mechanical energy of any system is potential energy and kinetic energy. So we will apply the conservation of mechanical energy. And conservation of first you should know what is conservation of mechanical energy. Conservation of mechanical energy. Conservation of mechanical energy. So conservation of mechanical energy means for a system, for a system, if there is a system, for that system, the initial potential energy plus initial kinetic energy is equal to final potential energy plus final kinetic energy of system. This is the conservation of mechanical energy. Now this we will apply, and how means this is not applicable everywhere. Here we are applying it because here there is no friction force. Okay, there is no friction force, or there is no work done by the external force. Friction force is absent. There will be only the gravitational force. There will be only the gravitational force. If the conservative forces are available, na, then we can apply the conservation of mechanical energy. If friction force is available, if friction force is involving, then we cannot apply. So conservation of mechanical energy we will apply. We will see the initial potential energy of this plus initial kinetic energy. What we will do? We will see the initial potential energy plus initial kinetic energy, and we will see final potential energy plus final kinetic energy, and these both will be equal. So initial potential energy of this mass is 0, and initial kinetic energy is also 0, because they are saying uh, mm, 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 mm. the meteorite starts from rest. If it is starting from rest, means its speed will be 0. If its speed will be 0, then its kinetic energy will be 0. Do you know what is the formula of the kinetic energy? Kinetic energy. If a mass m, if a mass m is moving with velocity v or speed v, what is the kinetic energy? The kinetic energy will be half mv square.
Yeah.
So if this v is 0, if v is 0 here, then the initial kinetic energy is 0, and initial potential energy is also 0. So this is 0. So initial potential energy is 0, initial kinetic energy is also 0. Now final potential energy, we calculated now final potential energy. Final potential energy is this minus gmm by r. So put the value minus g m divided by r. Final kinetic energy. Final kinetic energy means final velocity, the energy corresponding to final velocity. Final velocity is v, that we have to find. So half mv square we can write, half mv square. Now it is very easy. Now it is very easy. So this will become half mv square is equal to gmm by r. This is half mv square is equal to plus gmm by, so it will be plus now, plus g m into small m divided by r. From here this m will be cancel out, so the value of v you will get under root of 2 gm by r, 2 gm by r. Now we can calculate this value. 2 g value is 6.67 into 10 to the power minus 11 multiplied by mass of the earth. Mass of the earth is given as 6 into 10 to the power 24 kg. 6 into 10 to the power 24 kg. And radius of the earth is 6.4 into 10 to the power 6, I think. 10 to the power 6, I think. 6. So calculate this value, and this value you will get approximately equal to 11.18 into 10 to the power 3 meter per second. And when you can convert this in kilometer per second. Just do this calculation, please, fast.
Yes, sir, I got the same answer.
Hmm?
Yeah, I got the same answer, sir.
Getting now? Okay.
Yeah, I'm getting the answer. 11.18.
If this question will appear in your examination, then you should know how to do the calculation, and you should know the whole concept. I have not given this question. I have taken this question from your syllabus book. Okay, so maybe this question will appear in your exam, but you have to remember the conservation of mechanical energy. Okay, you have to remember the conservation of mechanical energy. Basically, this is a topic from the chapter work power energy. This is very, very important. So we have not do that.
Can
Work
I
power
take a
energy.
picture of this question?
Yeah, I will give you the time for noting down. Okay, so don't worry
Okay.
about that. We will solve the next question then. In your book, there is a little idea about this potential. Means they have not given this in an elaborated way. But if you will only know about the potential at a point P is equal to minus Gm by R. So this question you cannot solve. You should know the whole concept of the potential, so that you can solve this question. Otherwise, I don't think that you can solve this without the proper concept of the what is the potential, or the concept of the potential difference. Okay, this is the next question. This is the next question. So now you will see in this question, we will use the uh, variation of acceleration due to gravity, that derivation that we did. Okay, the formula we get by doing the derivation, we will use here in this question. Okay, so in this question, first read this question, take 1 minute and read this question properly. This is a little bit lengthy question, but this is very easy question. One minute you have. Hmm. Okay, Shavati, now see. Read it. Hmm?
Yes. Yeah.
Oh, okay. Now, see. The weight of a the weight of a passenger in an aircraft, the weight of a passenger in an aircraft on the runway is W. On the runway. Huh? His weight when the aircraft is flying at an altitude of 16 kilometers above the surface of the earth is WA. W is the weight. This W is the weight. This W is the weight on the surface of the earth, you can say, or on runway. Runway is on the surface of the earth, na? Have you seen the runway, na? So runway is on the surface of the earth, and
Yes.
suppose imagine like this. This is the runway. Okay, this is the runway, and here is the aircraft. Aircraft is moving like this, running like this, and after some time the aircraft will move, and it will attain some height. So here on the surface of the earth, the weight of the passenger is W, and when the aircraft will be here, when aircraft will be at a height of 16 kilometers, then the weight of the person is given as WA. So WA is that weight. So they are asking the percentage change in its weight is given by F. So percentage change in the weight is given by this. Okay. So this we have to find. Hmm? The percentage change F in his weight is given by F. This is equal to 100 into WA minus W divided by W. Taking the radius of the earth is this. Calculate F. First we have to find this F. F means percentage change in the weight of the passenger. Secondly, they are asking calculate also the percentage change in his gravitational potential energy. Percentage change P in his gravitational potential energy when he is on the surface, hmm, and when he is at a height of 16 kilometers above the surface of the earth. So, see, this is the earth. Okay, this is the earth, and my battery is low, so I have to change it. Hello, getting my voice? Hello.
Yeah, yes, sir.
Actually, just a minute. Hello, now, are you getting my voice?
Yes, sir.
Okay. Okay, so this is the Earth, and aircraft will be on the surface of the Earth. This is the surface. Aircraft will be on the surface of the Earth. So initially, the aircraft will be on the surface of the Earth, means here. So aircraft will be here. So passenger, you can say, will be here. This is the passenger here. And after some time, the passenger will be at a height of 16 kilometer. At a height of 16 kilometer. Somewhere here. Somewhere here. So here the weight is given. Here at the surface, the weight of the person is W. And here the weight of the person will be WA. The weight of the person is WA. This is given. And we have to find percentage change in the weight, means WA minus W divided by W into 100. This we have to find. So how we will find that? Okay. I told you that weight is mass into weight at any point. Weight at any position is equal to mass into acceleration due to gravity there. So here on the surface, the weight will be mass of the passenger multiplied by the acceleration due to gravity on the surface of the Earth. Weight at a location here will be mass into acceleration due to gravity there. And I also told you that when you will move away from the surface of the Earth, or when you will move up above the surface of the Earth, the acceleration due to gravity will decrease and weight will also decrease, because weight is mass into acceleration due to gravity. Weight is totally depending upon the G value. So this will be the weight. So what we will do, first we will calculate G value on the surface, and then we will calculate the G value at this location. Okay. So G value here, I told you the formula of acceleration due to gravity on the surface of the Earth. G on the surface of the Earth will be, radius of the Earth is given, mass of the Earth is this, gm by r square. Told you or not?
Yes.
The acceleration due to gravity on the surface of the Earth will be gm divided by r square. Now at a height h above the surface of the Earth, I also told you what will be the acceleration due to gravity when the body will be h height above the surface of the Earth. The formula was g dash is equal to gm divided by r plus h square. This distance will be r and this will be h, so it will be r plus h square. R plus h square. I told you that this will be the formula, and this formula we can convert into this form also. G dash is equal to G 1 plus h by r square. We can convert this formula into this also. And how to convert, I told you that what you will do, from this value you will calculate gm from here and you will put gm here. So the value of gm you can put from here, it will be gr square divided by
r plus h square. Now what you will do, this is g, r square will go here like this, r plus h square divided by r square. Now you will divide r plus h by r square. So this g dash value will become g divided by r by r 1 plus h by r and square of it. If you want, you can learn this formula directly. I told you this formula directly. The acceleration due to gravity in terms of the acceleration due to gravity on the surface of the earth. Here. I told you this formula now directly. Star is there. G dash is equal to G 1 plus Hy radius of the earth square. So you can use directly also. Okay. So finally you will get this formula. Now you can apply this formula. G dash is equal to G. We are calculating the G dash value here. 1 plus, what is the height? What is the height? 16 kilometer. Height is 16 kilometer. And what is the radius of the earth? When you will convert this value, na, radius of the earth. Radius of the earth is not given. Basically, the radius of the earth is 6400 kilometer. 6400 kilometer. That is the radius of the earth. Kilometer. So you will get G dash value as G is equal divided by 1 plus, this will become, you can cancel this, it will become 16 4 and 0 0. So it will become 1 by 400. So the value G dash you will get. Now what is the value of G on the surface? What is the value of G on the surface? Approximately equal to 9.8 meter per second square or Newton per kg. I told you. At surface of the earth, the value of G is this 9.8 meter per second square. And you will get that by putting all the values. Okay. So this value is 9.8. And this is 1 plus 1 by 400 will be, I think it will be 0. 1.0025. Okay, so this value will become G dash value will become 9.8 divided by 1 point, means this will be this is 0 point, 0.0025, so it will be 9.8 divided by 1.0025. The value of G dash you will have 9.77 meter per second square. Shafuddin, do this calculation fast, because I want that if this question will appear in exam, so that you are comfortable with the calculation. I have also done this I also did this calculation by calculator.
Yes, sir.
9.8 divided by 1.0025.
Yeah, I got the same answer. 9.75.
Okay. Now you have the value of G 9.8, you have value of G dash 9.77, and you have to calculate this value. You want to calculate this value, now you can calculate this value easily. F weight at a height h will be m into g dash minus w is mg, and this is divided by mg. So m will be cancel out. You can take m common from here, and m will be cancel out. So and this is multiplied by 100 also. So f, you will have g dash minus g divided by g. So you will have g dash by g minus 1. G dash value is 9.77 and g value is 9.8 minus 1 multiplied by 100. So when you will calculate this, you will get the answer negative of 0. I think it will be 0.30%, 0.3%. 30%. Negative means the value is decreasing. The value is decreasing. Now next part they are asking calculate also the percentage change P in its the gravitational potential energy. This is very simple. Gravitational potential energy means initially the body is here, finally the body is here. So initial gravitational potential energy minus gmm by r. Initial gravitation. What is the formula of the gravitational potential energy? U is equal to minus gmm divided by r. So copying this figure here. So initially the body is here. So initial potential energy will be minus g into mass of the earth multiplied by the mass of the body m divided by radius r. This is the initial potential energy. Final potential energy will be finally the body is here at a distance of r plus h. So it will be gm divided by r plus h, and you have to find the percentage change in the potential energy, means P. Percentage change in the potential energy. This will be final potential energy minus initial percentage change. Whenever you are calculating percentage change, so you will write final minus initial divided by initial multiplied by 100. Final minus initial divided by initial multiplied by 100. So final potential energy is this minus g into capital M into small m divided by r plus h minus initial potential energy g into m divided by r divided by initial. Initial is minus of g into m divided by r. Now which terms will be cancelled out? This gm and m, this gm and m, this gm and m will be cancelled out. So you will have minus 1 upon r plus h, and this minus and this minus become plus. So it will become plus 1 by r and divided by 1 by r. So now here you can take LCM. Here you can take LCM. So LCM will be r plus h. So now you will multiply this side r. It will become minus r plus h. Okay, and here is 1 by r. R and r will be cancelled out, and this r and this r will be cancelled out. So you will have h divided by r plus h, and this is multiplied by 100 also. Okay, so you can multiply it with 100 also. 100 multiplied by 100, because we are calculating the percentage change multiplied by 100. So now h is 16 kilometer. R plus h, r is 6400 kilometer plus it is 16 kilometer multiplied by 100. So it will be 16 divided by 6416 multiplied by 100. The answer will be, when you will calculate this by the calculator, you will get 0.24%. So it means this potential energy P, change in potential energy, is coming out to be positive. Percentage change here is positive, means potential energy is increasing. Negative means decreasing. Positive means increasing. Okay, Shafdin?
Yes, sir. Sir, can I go to the washroom? Okay, sir. Okay, sir.
So in this way you have to solve the questions. Okay, now you can take the screenshot from this already did. So take the screenshot from here.
Done, sir. 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 Yeah. Done.
Have you checked this answer?
Yeah, sir. 0.24.
0.24. And this please check this answer also.
Yes, sir, I got the same answer. Negative 0.30. Yeah, I got the same.
Same answer, no? Negative means decreasing. Weight will decrease when you will move. Okay, so let's recap once again what we did till now in this chapter. Newton's law of gravitation. Main things I will recall. Gravitational field. After that, we have done acceleration due to gravity, variation of acceleration due to gravity. After that, we did gravitational potential. After that, we did potential energy. After that, gravitational potential energy. Okay. Change in potential energy above the surface of the earth. This is this topic is basically covered in these numericals also. Numericals. So separately. Okay. So what we have to do? Okay, so I am giving this as a question. Shavardi, you will try this question. I am giving, this is the earth having mass m and radius r, and this is one mass m. This mass m is moved from this position to this position, and the distance is this distance is h. This distance, the mass is moved to a distance h. You have to find change in potential energy. Find change in potential energy. Find change in potential energy of mass when it is taken from surface of earth to height if h to height h above the surface of earth, above the surface of earth. So basically this is homework for you. Please try it. Please try it. Take the help of notes. Try this question. You have to find the change in the potential energy of this mass.
Okay, sir. So this one I submit to you tomorrow.